Hello everyone, welcome to my channel. Now in this video we are going to discuss this pulley mass system in a bit detail. Now this is the most simple example wherein we have a fixed pulley attached to a rigid support, and these are two masses M1 and M2. This is a string attached to mass M1 passing over the pulley, and the other end is attached to mass M2. Okay, now this string, this is the ideal string. Now for ideal string, we'll assume that this string is massless and inextensible. That is, its length is constant and its mass is 0. Its mass can be ignored. Okay. Now in that case, throughout the string you will have the same tension. Now tension, we know that the force exerted by string on the bodies attached to it. Okay, so on this side, see this mass, it is pulled by the string in the upward direction. So on this mass the tension is in upward direction, T. Okay, now this is the same string passing over the pulley attached to this mass. So here also throughout the string the tension is same. For this massless inextensible string, throughout the string the tension will be the same. So for mass M2, again this tension is directed in upward direction. So this tension is the force exerted by string on bodies connected to it. Okay, so now this same string is attached to this pulley. Now if you observe this pulley system, so this pulley is attached to the rigid support and these are the two strings. Okay, now this, for this mass, tension T is in the upward direction. For this pulley, tension T will be in the downward direction. So and the other end also similarly it is in the downward direction. Okay, now suppose at this point the tension in this string is Tp. Okay, now if you observe this part, okay, now for this part, see, Tp is the net force in the upward direction for this pulley, and T and T, these two tensions are acting in the downward direction. So Tp, net force, upward force minus total downward force is 2T, is equal to mass of pulley into acceleration of the pulley. Mp is the mass of this pulley. Okay, now for this case, in laws of motion, this string is assumed to be massless. This pulley is also assumed to be massless. Okay, now pulley is also assumed to be massless. So for Mp is equal to 0. If Mp is equal to 0, Tp minus 2T will also be 0. So that is Tp is equal to 2T. So that means tension on this part will be equal to 2 times the tension. Okay, so this side total downward force is T, total upward force is also T, net force of the pulley is 0. Okay, why force is 0? Because the mass of the pulley is 0. Okay, so this is one important conclusion. Now if you observe this mass M1, okay, this M1 mass, M1G is the weight of this mass acting in downward direction, M2G is the weight of this mass acting in the downward direction. Okay, now assuming that M2 is greater than M1. Now if M2 is greater than M1, in that case this mass will come downward, this mass will come upward. Okay, it will go upward. Now since this is connected to the same string and the string is inextensible, that means if this point of the string is coming downward with acceleration A, this point of the string should move upward with same acceleration A. Okay, so acceleration of this mass is A in the upward direction, acceleration of M2 is A in the downward direction. Now if you observe this mass M1G, mass M1, it is acted upon by tension T in the upward direction, force M1G in the downward direction. Okay, but it is moving in the upward direction. So that means this force is greater than this force. So T minus M1G is equal to net force. Net force is mass into acceleration. So it is M1 into A. Okay. Now similarly, if you observe for the other mass, m2g, it is acting in downward direction, t is acting in upward direction, but it is coming down. So this force is greater than this force. So m2g minus t is equal to m2 into a. Okay. So these are the two equations. Now if we add these two equations, we get this t and t cancels out. So we have m2 minus m1 into g is equal to m1 plus m2 into a. So this gives acceleration is equal to m2 minus m1 into g divided by m1 plus m2. So this is the acceleration of each block. Okay. Now if you substitute this acceleration over any one of the equation, you can get the value of t. Okay. So this t, it will come out to be twice m1 m2 g divided by m1 plus m2. So this is the tension in the string. Okay. Now one more thing which can be observed for the same system. See, for this string, the string is attached from mass m1 to mass m2. Okay. Now let's say L is the length of the string. L is the length of the string. Okay. Now suppose this length at the present moment, this length is x1, and this length is x2. Okay. I have ignored the length which is in this part of the pulley. I am assuming that pulley's size is also very negligible. Okay. Now in that case, if the size of the pulley is negligible, so in that case I can write L is the total length of the string and it is equal to x1 plus x2. Okay. Now see, when this system moves, m2 comes downward, m1 goes upward, the value of x1 and x2 changes, but the L will remain same. Okay. So if I differentiate this with respect to time, dl by dt is equal to dx1 by dt plus dx2 by dt. Okay. But dl by dt, length of the string is constant, so this is 0. dx1 by dt is the length of rate of change of this length is equal to the velocity with which this block is moving, this mass m1 is moving. So that gives v1, this is v1, similarly this is v2 is equal to 0. Okay. So that gives v1 is equal to minus v2. So that means both the two blocks will move with same velocity but with opposite direction. So opposite direction, for that we have this minus sign. Okay. Now similarly, if you differentiate this once again, you get a1 is equal to a2. That means if you differentiate this once again, you will get a1 is equal to a2. So that means the two blocks will move with same acceleration, a. Both the acceleration are same. Okay. So this is second part of the observation. Okay. So one more thing before we proceed further, one more thing to be learned is that for a pulley mass system, the algebraic sum of the total work done by the tension is always 0. Okay. The algebraic sum by the work done by tension is, for the system, it is 0. Okay. For a pulley mass system, before we proceed further, we also need to know one more thing, that for a pulley mass system, the algebraic sum of the work done by tension for the complete system is always 0. Okay. So what does it imply? How we have to use it? See, for this block, tension T is acting in the upward direction and it moves through a distance x1. Okay. And tension and displacement, they are in the same direction. So in this case, work done is positive. Okay. For this case, see, tension is acting in the upward direction and displacement x2, it is in the downward direction. So for this, work done is negative. Work done is negative. Why? Because we know that work done, it is the dot product of force and displacement. Okay. So if force and displacement, they are in the same direction, the F dot S means Fs cos theta. Okay. Now if force and displacement, they are in the same direction, theta is 0. So work done is positive. If force and displacement are in opposite direction, theta is 180 degree. In this case, tension in upward direction, displacement x2 is in the downward direction. So theta is 180 degree, cos 180 is negative, so work done will be negative. So for this case, work done by this tension, it is T into x1. Okay, work done by this tension, it is plus minus T x2 is equal to 0. Okay, total work done by the tension, it is 0. Okay, why this is positive? T and x1, they are in the same direction. In this case, T and x2, they are in opposite direction, so work done is negative. Okay, so this gives T x1 is equal to T x2. Okay, so T cancels out. So we have x1 is equal to x2. Correct. Why? Because see, if this block moves through a distance x1, this block will also move through a distance x2, and x1 and x2 will be equal. Why? Because this string is inextensible. So again we are getting the same result. Both the ends will have same displacement, both the ends will have, so they have same displacement, they will have same velocity, they will have same acceleration. Okay, so this is another way of observing the same concept, but this concept will be applied in the next case. So we have this pulley mass system. See, this is block of mass m1, this string passing over the pulley, and this is another pulley, this is another string. This end of the string is fixed to this support, so this is immovable. This is a string passing over the pulley, and this is attached to mass m2. So basically we have two movable blocks and one movable pulley. Okay, so now if we observe block m1, okay, so this block is, this is the string, so throughout the string we need to have same tension. Okay, same tension. So this is tension T on block of mass m1, and here again this is tension T. Okay, now suppose here the tension is T1, and this is again, this is same string, so this is also T1. Okay, now in the previous example, in this case we have seen that if this is T, this is T. Okay, then tension in the pulley was twice T. Okay, now similarly in this case, if you see, this is T. Okay, so this plus this should be equal to this, so that means here the tension, this should be equal to T by 2, this is also equal to T by 2. Okay, so this is T, here the tension will be T by 2, here also the tension will be T by 2. Okay, now let's frame the equation for mass m1 and m2. Now this mass m1, suppose m2 is greater than m2, m2 is coming down, m1 is going up. So for m1, what do we have? So this is m1, tension T acting in the upward direction, and this is m1g. Okay, so now it moves upward, so this is, it moves upward with acceleration a. Now since it is moving upward, this force will be greater than this force, tension will be greater than m1g, so net force will be T minus m1g is equal to m1a. Okay, now for m2 we don't know what is the acceleration, so let's take its acceleration to be a2. Okay, so for m2 similarly, m2 upward direction, the tension is T by 2, its weight is m2g, it is coming down with acceleration a2. So this m2 is acted upon by a force m2g in the downward direction, T by 2 in the upward direction. It is coming down, so m2g is greater than T by 2, so it is m2g minus T by 2 is equal to m2 a2. Okay, so this is the equation for force. Okay, now let us apply the equation for zero work done. Okay, now suppose this block moves through a distance x1 and this block moves through a distance x2. Okay, for this it is x1, for this it is x2. So work done, see in this case tension and displacement they are in the same direction. In this case tension and displacement they are in opposite direction. So here work done will be negative, here work done will be positive. But what will be the total work done? Total work done will be 0. Okay, so we have, for this it is tension into displacement, force into displacement. So T x1, for this tension is T by 2, so minus T by 2 into x2 is equal to 0. Okay, so this gives Tx1 is equal to T by 2 x2. So this T cancels out. So this gives twice x1 is equal to x2. Twice x1 is equal to x2. Okay, so if I differentiate this, I get twice v1 is equal to v2. If I again differentiate it, twice a is equal to a2. v1 is the velocity of mass m1, and for mass m1 we have taken the acceleration to be a. Okay, so a is the acceleration. So this is the relation between a2 and this is the relation in acceleration of mass m2 and mass m1. So now I know I can substitute, instead of a2 I can write as twice a. Okay, so by solving these two equations we can find the value of t and a. Okay, there are two equations and two unknowns. So from this you can get the value of t, you can get the value of t, and you can get the value of a. So you can identify the acceleration and the tension of the system. So this is how you can solve such problems, by applying the equation for force and applying the equation for zero work done.